Hello, today we're going to talk about beats, resonance, and harmonics. Alright, the first thing we're going to talk about is constructive interference and destructive interference. So constructive interference. That is basically when you create a bigger wave by combining two of the same waves. So if I have a wave here, and let's say it has an amplitude of 1. Alright, so that's from the medium up there. Let's say that's 1. And it gets joined by a second wave and that amplitude is also 1. Same wave hits at the same time. What that does is then you add these two together and you get a wave that has an amplitude of 2. So that's constructive interference. When these two waves that are exactly the same hit each other, they increase, they add together. So that's constructive interference. The other one here is called, I probably didn't have to erase that whole thing, destructive interference. So destructive interference is when you have a wave, such as this one right here, but then you add to it the exact opposite wave. Oops, that's a horrible wave. Let me redraw that. Yeah, right there. There we go. That's a horrible wave too, but it's alright. So these are exact opposite. Where this has a crest, this has a trough. Where this has a trough, that has a crest. And so on and so forth. So all the time, they're canceling each other out. The amplitude is still the same. But in this case, when you combine them, so think of this as +1. If that's +1, and this is -1, you get nothing. There's no sound. That's why it's called destructive interference. Because you put the two sounds together, I lost my top. Put the two sounds together, it creates no noise. So that's destructive interference. So constructive is the same two waves hitting each other at the same time. They grow, you combine them. If they're two different ones, so when you have a trough and a crest that hit at the same time, same amplitude, they cancel each other out. Alright, calculating beats. So calculating beats is the difference in frequencies is equal to the number of beats per second. Alright, so the difference in the frequencies between two things is equal to your beats per second. So here's my first example. So I have two tuning forks that are hit exactly at the same time, simultaneously. One gives me 232 hertz, the other gives me 256 hertz. So to find how many beats per second that is, I just subtract these two. So 256 minus 232, which is the difference in frequencies, gives me 24. So 24 hertz or 24 beats per second. So it's just subtracting the two that you have. Another example, my second one down here. If I'm trying to tune a piano, right, and I have an E tuning fork, and I hit the E tuning fork, and I get 276 hertz, and let me say this right, and 200, and I hear 6 beats. 6 beats are heard, yes. I'm trying to remember this actual question. All right, so how off is the piano? So technically in this case, my piano is my second tuning fork. So I have to figure out going backwards is all this is. So now I know what my answer is going to be, which is 6. I know, do this. I know my answer is going to be 6 hertz. So what could this possibly be? If this is my tuning fork, what could my piano be? All right, my piano could actually be 6 above or 6 below. So my piano E could be 282, because 282 minus 276 gives me 6 hertz, or 270. It could be one or the other. So as long as those 6 beats are heard, you know it's one way or the other. Now if I was asking for, on the high end, what could it be? All right, it could be 282 if I know it's too high. If I know it's too low, it could be 276. So that's how you calculate beats per second. You just subtract the 2 you heard, or the 2, to get how many beats per second you have. All right, resonance. Resonance is a weird thing. I'm gonna read the actual definition. It's a tendency of an object to vibrate at maximum amplitude at specific frequencies. Resonance frequencies is an object's natural frequency of vibration determined by the physical qualities and dimensions of the object. So resonance is basically, you can look up videos on it sometimes. So everything has a natural frequency. So when it hits that natural frequency, it'll start moving up and down. So just like you can look at videos of bridges, wind will hit it at a certain frequency and it'll start shaking back and forth because resonance makes it vibrate at its maximum amplitude. So it actually starts moving back and forth, and bridges is shattered because of this. You can look up videos online of it. It's actually pretty interesting, but that's what resonance is. It's just the natural frequency. Resonance frequency is just the natural frequency of an object. All right, and our last thing is harmonics. So in harmonics, basically all you need to know is you have your fundamental frequency, then every frequency after that just doubles it. So I should have erased this first, but I'll erase it now, and you can watch me erase it, because that's always exciting, is watching someone erase something. So harmonics. So if I have an original frequency of, what I write down here, 68 hertz is my fundamental frequency. Fundamental frequency. What is my second frequency going to be? So I multiply that by 2. And I get 136. At the end of the day, my brain's getting fried. So 136 hertz. If I want to know what my third frequency was, I multiply 68 times 3. That'd give me 204 hertz. All right. So all of these can be harmonics. You have your fundamental frequency, then your second, then your third, so on and so forth. All right, and that's basically all you need to know about harmonics for this. I know it wasn't very descriptive. All right, this has been beats, resonance, and harmonics. I hope it helps, and good luck.